Right now, three of humanity's most sophisticated spacecraft are racing toward an invisible cloud of dust. Not just any dust, particles that were forged in orbit around a star we can't even identify. A star that might have died before Earth was born. The target? A rogue comet called 3I Atlas. And yes, that I stands for interstellar. While you were going about your day on October 29th, this ancient traveler completed the most dangerous part of its journey through our solar system. It screamed past the sun at velocities that would take you from New York to Los Angeles in barely 2 minutes. And during those critical hours, when it made its closest approach, every telescope on Earth was useless. The sun itself blocked our view. That timing? It's either the universe's most perfect coincidence or something worth investigating very, very carefully. I'm going to walk you through what makes this object so profoundly strange, why some of the world's top scientists are watching it like hawks, and what the next few months might reveal about where we actually stand in this galaxy. Because if the data coming back from these spacecraft shows what some researchers suspect, we're going to have to rethink what we thought we knew about objects that drift between the stars. If you're into space mysteries that are unfolding in real time, hit subscribe. This story is far from over. Let me tell you about a ghost. Researchers in Spain spent months trying to solve what should have been a straightforward puzzle. Every object in motion has a source. Every trajectory has an origin. So, when 3I Atlas came sailing through our solar system, scientists did what they always do. They ran the math backward. The team, working under Xavier Perez Cutoto at the University of A Coruña, had access to something extraordinary: the complete stellar census compiled by the Gaia Space Observatory. Gaia has been mapping our galaxy with unprecedented precision for over a decade, tracking the positions and movements of more than 1 billion stars. They created a simulation. They took 3I Atlas's current trajectory, its velocity, and they rewound it like a cosmic videotape, 10 million years into the past. They watched this object's path thread backward through the Milky Way, looking for the moment when it would have been close enough to a star to be gravitationally captured, then ejected. The simulation identified 93 possible stellar encounters. Moments when 3I Atlas passed near enough to a star that their gravitational interaction could have altered its course. 62 of those encounters looked significant enough to investigate further. Here's what they found. Nothing. Not a single encounter was close enough or lasted long enough to definitively bend this comet's path into the trajectory we see today. They couldn't pinpoint a parent star. They couldn't identify a home system. Think about that for a second. We have a detailed map of 1 billion stars. We have supercomputers that can simulate gravitational interactions across millions of years. And this object's origin remains a complete mystery. The best guess? It came from somewhere in the Milky Way's thin disk, the flattened region where younger star systems congregate. But somewhere in the thin disk is like saying someone is somewhere in Asia. We're talking about a region containing billions of star systems spread across tens of thousands of light years. The research paper floats an intriguing possibility. 3I Atlas might have been ejected from a protoplanetary disk during the chaotic early formation of a star system. If that's true, this chunk of ice and rock could have been wandering the galaxy for billions of years. It might have been launched into the dark before our own sun even ignited. October 3rd, 2025, Mars orbit. The European Space Agency's ExoMars Trace Gas Orbiter wasn't designed to photograph comets. Its camera system, called CASSIS, is built for high-resolution surface imaging, from an altitude of a few hundred miles. It's meant to capture details of Martian cliffs and crater floors, not faint objects millions of miles away in deep space. But when 3I Atlas came within 20 million miles of Mars, someone at ESA decided to try anyway. To give you a sense of the technical challenge, imagine trying to photograph a smartphone resting on the moon's surface from your backyard. ESA's own press release used exactly that comparison. The comet was too far, too faint, and moving too fast for what Cassis was designed to do. They got the image anyway. What showed up in those photographs was subtle but unmistakable. A small, fuzzy dot surrounded by a visible coma. That glowing envelope of gas and dust that forms when solar radiation starts vaporizing a comet's surface. The coma was already active, even though 3I Atlas was still millions of miles from its closest approach. That told researchers something important. This object wasn't inert. It was already responding to our sun's energy, already venting material into space. The close encounter was still weeks away, and the visitor was already waking up. 11 days later, October 14th, astronomers at Gemini South Observatory in Chile aimed their multi-object spectrograph at 3I Atlas. They took 159 separate exposures, each lasting 50 seconds, then stacked them into a composite image. What they captured was remarkable. A brilliant jet of material was erupting from the comet's nucleus, extending roughly 33,000 feet into space. But here's the detail that made researchers pause. The jet was pointing directly toward the sun. That's backward. Comet jets typically spray outward from the sun, driven by solar radiation pressure and vaporizing ice. Sometimes they point sideways, perpendicular to the sun's direction. But a jet aimed sunward? That's unusual. It suggests something specific about the comet's rotation, or its internal structure, or the distribution of volatile materials beneath its surface. It's like watching water spray toward a fire instead of away from it. It means there's asymmetry. A focused release of material from a particular region of the surface, oriented in a way that defies the normal pattern, almost as if the object is venting from a nozzle. That same day, something else happened. The Punch satellite constellation picked up 3I Atlas in their imaging data. Punch, the polarimeter to unify the corona and heliosphere, wasn't looking for comets. These satellites study the sun's outer atmosphere and the solar wind. They monitor the stream of charged particles that flows constantly from our star, but there in their data, clear as day, was 3I Atlas. Independent researchers Thomas Lehman and Marshall Eubanks processed the Punch images and confirmed the position matched the predicted coordinates perfectly, which meant the comet was now visible in wavelengths, specifically tuned to detect solar wind interactions. It was beginning to interact with the sun's magnetic environment. October 29th, 2025, 11:47 a.m. UTC, Perihelion. At that exact moment, 3I Atlas reached its closest approach to the Sun, 126 million miles, just inside the orbit of Mars. For context, that's still far enough that there was never any danger to Earth. But for a comet, that's deep inside the fire. At that distance, the Sun's radiation delivers approximately 770 watts of energy per square meter of surface area. Imagine focusing the output of 33 nuclear reactors onto a single object a few miles across. Every square foot of this comet was being blasted with heat equivalent to 7 high-powered space heaters running simultaneously. And this wasn't happening during a quiet phase of solar activity. We're currently at solar maximum, the peak of the sun's 11-year cycle. Sunspots are proliferating. Coronal mass ejections are launching billions of tons of plasma into space. The sun's magnetic field is in the process of flipping its polarity. The star is as violent and chaotic as it gets. 3I Atlas chose this exact moment to dive through the chaos. Now here's the part that has some researchers very focused on the details. When any object passes through perihelion, it's experiencing maximum velocity and minimum altitude in the sun's gravitational well. This creates what's known in orbital mechanics as the Oberth effect. If you want to change an object's trajectory as efficiently as possible, this is the moment to do it. A small thrust applied at perihelion produces a dramatically larger change in the final orbit than the same thrust applied anywhere else. For a spacecraft, this is the prime moment to fire your engines. For 3I Atlas, this was the moment when even a small course correction would have the biggest impact. And during those hours, we couldn't see it. From Earth's perspective, the comet was directly behind the Sun, total solar occultation. Every ground-based telescope was blind, every optical observatory was useless. If something changed during those critical hours, we missed it. An amateur astronomer named Worawat Boonpla later reviewed footage from the GOES 19 weather satellite and identified what appeared to be 3I Atlas moving through the Sun's corona. If that identification is correct, it would mark the first time an interstellar object has ever been captured in coronagraph imagery during perihelion passage. NASA hasn't officially confirmed the sighting. The recent government shutdown created what some observers are calling a communications blackout that has delayed official statements. But the footage exists, and independent analysts are examining it. Here's where the story takes an interesting turn. The International Asteroid Warning Network, a program operating under the United Nations Office for Outer Space Affairs, initiated what they're calling a coordinated planetary defense observation campaign for 3I Atlas. Read that again. A planetary defense campaign for an interstellar object. This is the first time the UN has ever backed a coordinated observational effort targeting something from outside our solar system. The official justification is training, practice for future potential threats, a dry run to test international coordination protocols. But the timing raises questions. According to internal communications, the network launched this investigation after 3I Atlas began displaying what they described as anomalous characteristics. The documents don't specify what those characteristics are. Around the same time, Dr. Avi Loeb, the Harvard astrophysicist who chairs the astronomy department and founded the Galileo project, began directing resources toward 3I Atlas observation. Loeb is a controversial figure in astronomy. He's the scientist who suggested that Oumuamua, the first confirmed interstellar visitor in 2017, might have been an artificial probe. That hypothesis earned him both ridicule and attention. Loeb isn't claiming 3I Atlas is extraterrestrial technology, but he is arguing that we need to gather data rigorously enough to rule out possibilities that might seem unlikely. His Galileo project has deployed 3 separate observatory networks to monitor the object. He's also requested that radio telescopes listen for any electromagnetic emissions that might indicate artificial activity. Multiple facilities are now listening. Loeb recently appeared on Joe Rogan's podcast and revealed something that's been bubbling in the scientific community. On October 2nd, NASA's Mars Reconnaissance Orbiter, specifically its HiRISE camera, the most powerful imaging system we've ever sent to another planet, was positioned to photograph 3I Atlas from approximately 19 million miles away. According to Loeb, this would have been the highest resolution image ever captured of an interstellar object. HiRISE can resolve features on Mars as small as a kitchen table from orbit. Pointed at 3I Atlas from 19 million miles, it should have captured unprecedented detail. Loeb wrote to the principal investigator requesting access to the image. He received no response. NASA has not confirmed whether the photograph exists. They haven't released it. They haven't denied it. Congresswoman Anna Paulina Luna has now gotten involved, reportedly working to compel the release of any HiRISE imagery of 3I Atlas to the scientific community. The question is straightforward. If we have a clear, high-resolution photograph of an interstellar visitor from our best planetary camera, why hasn't it been made public? Right now, as you're reading this, 3 spacecraft are maneuvering into position for an opportunity that has never existed before in human history. ESA's Hera mission, NASA's Europa Clipper, and ESA's JUICE spacecraft are all positioned along trajectories that could take them through or very close to 3I Atlas's ion tail, the stream of charged particles that trails behind the comet as solar wind strips material from its surface. Hera had an intercept window between October 25th and November 1st. Europa Clipper's window opened on October 30th and extends through November 6th. JUICE's observation window runs from November 2nd through November 25th, right as the comet reaches peak outgassing activity. These aren't purpose-built comet missions. All three spacecraft are heading to other destinations. Hera is bound for the Didymos asteroid system. Europa Clipper is heading to Jupiter's moon Europa. JUICE is targeting Jupiter's icy moons, Ganymede, Callisto, and Europa. But their trajectories happen to align with 3I Atlas's path. And mission planners recognized the opportunity. If any of these spacecraft can sample the tail, if their instruments can detect heavy ions, exotic isotopes, or organic compounds not typically found in solar system objects, it would represent the first time humanity has ever directly analyzed material from another star system. Not from a meteorite that fell to Earth. Not from spectroscopic analysis at a distance. Direct sampling. Instruments touching particles that formed in orbit around a star we can't identify, possibly billions of years ago. The stated objective of these observations is exactly that. First contact with confirmed extrasolar material. There's a complication with JUICE. The spacecraft is currently using its large, high-gain antenna as a heat shield, which limits data transmission to a smaller secondary antenna. The observation data is being recorded, but it won't be transmitted back to Earth until early 2026, which means we wait. So here's where we stand. 3I Atlas survived its perihelion passage. It's now on an outbound trajectory, racing back toward the outer solar system and eventually the interstellar void. Its date with our sun is over. The most dangerous part of the journey is complete. But the most interesting part is just beginning. Over the next few weeks, observation data will flow in. Spectra from ground-based telescopes. Imaging from space-based observatories. And eventually, in early 2026, the direct sampling data from JUICE, Hera, and Europa Clipper. We'll learn its composition, we'll confirm its trajectory, we'll measure its rotation, its outgassing rate, its size, and its structure. We'll build a comprehensive profile of this ancient wanderer that stumbled through our cosmic neighborhood. And maybe, just maybe, we'll learn something that changes how we think about the space between the stars. Because that's what these objects represent. They're not just chunks of ice. They're ambassadors from the galaxy itself. Evidence that the space between stars isn't empty, dead void, but a vast ocean filled with debris from billions of planetary systems, all slowly mixing, all drifting through the dark, occasionally passing close enough to a star to be seen. Every time we study one of these visitors, we're sampling the galaxy without having to leave home. If you want to follow this story as it develops, subscribe to this channel. I'll be covering every major development as the data comes in. Drop a comment below with your thoughts. Do you think 3I Atlas is just an unusual comet working through natural processes? Or is there something about this object that deserves deeper investigation? And if you found this deep dive valuable, share it with someone who appreciates a good mystery that's actually happening right now, in real time, above our heads. This is science at its best. Uncertain, unfolding, and absolutely fascinating. Thanks for watching. I'll see you in the next one.